All right, so in this second example, it says find the volume of the solid in which the base is a circle. It doesn't have to be a pretty shape, it can be anything really. But it's centered around the origin with radius of 2 units whose cross sections are described in these 5 different examples. All right, so first of all, in the last problem, we were given the equations, right? We were given f of x was 1 minus x over 2, and g of x was negative 1 plus x over 2. This time we don't have an equation. All they tell us is that we have a circle. Whoa. We have a circle centered at 0, 0, and the radius is 2. So we gotta remember, all the way back from geometry, how do you write the equation of a circle? So you might remember it's x minus h squared plus y minus k squared is equal to r squared, where h and k is the center of the circle. But this one's pretty easy because it's just centered at 0, 0. So this would be x squared plus y squared is equal to 4, which is the radius squared. So if I want to solve for y, I'd have y is equal to 4 minus x squared. I have actually the square root of that. So y is equal to the positive and negative square root. So the top of it is the positive square root of 4 minus x squared. And then the negative square root of 4 minus x squared would be the bottom. And together they make up the circle, but it's not a function. All right, so we got to keep that in mind. Let's see, I'm going to write that again off to the side. So I've got y is equal to plus or minus the square root of 4 minus x squared. Okay, so the cross sections are perpendicular. The cross sections are perpendicular to the x-axis, and this time they're squares. So they're going to be squares coming up and out. So toward the edges, the squares are going to be a little smaller. In the middle, the squares are going to be bigger. And how we find that is we're going to integrate an infinite number of areas. So I'm thinking, okay, volume is equal to the integral from negative 2 to 2. This is negative 2. This is to 2. This is x's. And it's the area of a square, so the side length squared. So each side length, something I gotta know extra, side length is the distance between the two of them, right? So it's going to be the top 4 minus x squared minus the bottom, but the bottom is negative, right? I'm subtracting the bottom, but since the bottom is negative in and of itself, it's going to give us the square root of 4 minus x squared plus the square root of 4 minus x squared. So each side length is 2 square root of 4 minus x squared. All right, so that's the side length. The side length squared would be 4 minus x squared. Whoops, that would give us the wrong answer, right there, squared, dx. So I'm going to integrate that, and then that will tell me the volume. So I would distribute the 4 before I integrate. This will give me 16 minus 4x squared dx. Integrate both sides, or integrate it, so this would be 16x minus 4 over 3 x cubed. Evaluate from negative 2 to 2. And that would be, okay, plug in 2. The new part is finding that side length, right? To try to represent the area of a square in terms of that function that we're given. So volume would equal, okay, plug in 2, so 16 times 2 would be 32 minus 2 cubed, which is 8 times 4 is 32 minus 32 over 3 minus, whenever I get my plug in, negative 2, be negative 32. So I want to be in plus the same thing. So negative minus, so this is going to be, so 32 plus 32 would be 64. Negative 32 minus positive 32 would be negative 64 over 3. I could probably just stop here. If it's a free response question, I could have stopped right here, right? But I'm just going to keep going. This would be 192 over 3, get a common denominator, which is 128 over 3. Does that go into that? 2. Yeah, I don't think so. All right, so that'd be it. All right, next one. This time the cross sections they're still coming out of the circle. This time instead of squares, they are semicircles. So I've got to remember the volume is equal to the integral from A to B, and it's going to be the area of whatever that shape is. So I got to think, okay, what's the area? The area of a semicircle. The semicircle, the area of semicircle is 1/2 pi times the radius squared. So the radius is just distance from, like, I guess, like each semicircle would just be that distance, right? Because it's coming out of if it's coming up 3D, the radius is still going to be the distance from, or it's just the radius is just going to be the distance from the x-axis to either one of those. So the radius will just be 4 minus x squared. All right, so semicircle will be 1/2 pi times the radius squared. So it'll just be 4 minus x squared dx. So this would be volume is equal to 1/2 or pi over 2, take it on the outside, 4 minus x squared dx. So antiderivative is going to be pi over 2. Antiderivative would be what we just got a second ago. 16x minus 4/3 x cubed, evaluated from -2 to 2. And if I went through and multiply that all together, I would get 16 pi over 3 if I reduce it, but we're just not going to do that. You would plug in 2, All right, C, I didn't, for some reason, put a picture on here, but we'll just write it. It's on the notes. C is the cross sections. Can't spell cross sections. Are perpendicular to the x-axis, and they are equilateral triangles. Okay, so I've got this circle, and out of each, there's going to be an equilateral triangle coming out of it. So all the sides are going to be the same. So to find the volume, it's still the same process. It's the integral from -2 to 2. This time it's the area of a triangle, which is 1/2 base of the triangle times the height of the triangle. Now the base of the triangle is that whole distance, right? Which we already know is a side length of a square from part A. So we know the base. I'm going to write it in just so it feels like I'm like doing something, being productive. It would be, I might take that 1/2 out also. The base would be, what do we get? 2 square root of 4 minus x squared. And then the height, oh boy, it's going to be that distance, which is what we did as part of the problem last time. So I've got this equilateral triangle. All the sides are the same. Each one is 2 square roots of 4 minus x squared. And then I need to find, I guess this base, we'll make it black so it matches the picture. Okay, the height of that. So I also know this is 2 square root of 4 minus x squared. And if I was just drawing this half of the triangle, this would just be 1 of those square roots of 4 minus x squared, and I could call this the height. So I've got h squared plus 4 minus x squared is equal to this squared, so your Pythagorean theorem. and then we're going to solve for h. So h squared would be equal to, this would be what, 16 minus 4x squared. Okay, sorry, 16 minus 4, so that'd be 12. And then add x squared, so it'd be negative 3x squared. So h would be the square root, the positive version of 12 minus 3x squared. Okay, so now I have to integrate this. Okay, so now I think, okay, how would I do this? If I'm integrating that, let's see. What did I do on my answer key? I did this earlier. 1/2 base times height. Got something a little bit different on my answer key. What is that? Root 3 times square root of... What did I do wrong? That's the base. Oh, okay. So there's the trick to this, and I kind of forgot about this. I should be reviewing this a little bit more before I start talking on this. But I factor out the 3 within there, and this would be 4 minus x squared, and look at there, it just happens to be the exact same thing as that. So I would rewrite this as the square root of 3 times the square root of 4 minus x squared dx to 4 minus x squared integral negative 2 to 2 of 1/2. And when I do that, the 1/2 and the 2 will cancel. And then I would have, this would be volume is equal to integral from negative 2 to 2. I would bring the root 3 out in front. And then the square root of 4 minus x squared times the square root of 4 minus x squared would be 4 minus x squared dx. Antiderivative of both sides, or not both sides, but find the antiderivative, would be 4x minus x cubed to the 1/3. Evaluate from negative 2 to 2. And if I went through and simplified this all the way down, I don't think there's anything too tricky about that. This is what I got before. So you can practice simplifying and getting to that point. All right, last two. Okay, this time the cross sections are perpendicular to the x-axis, and this time there are isosceles right triangles whose hypotenuse resides along the base. So I have that circle, and I've got this triangle where the two sides that are equal are the blue ones, and the hypotenuse is going along the base. All right, so I need to find the area of a triangle. This is volume is equal to the integration from negative 2 to 2, area of a triangle, which is 1/2 base times the height. The base is going to be that red line distance, right? Which is the same as it has been before. So I'm going to go ahead and write that in there. It's a negative 2 to 2. The base is 2 square roots of 4 minus x squared. And then, what would I do now? Oh, do I even need to do that? I don't think I need to do that. Let's see. The area of the triangle would just be this base times this height. That would be a lot easier. The area, I'm going to find I could do it this way and then go through and find that the base is that number. But I think it'd be easier, I don't know, maybe, yeah, it might be just as easy to know if I've got this right triangle where the hypotenuse is 2 square roots of 4 minus x squared. This is just, we call this base, we could call this base. They're the same thing, right? Call it y. But it's going to be your base and height, it's going to be the same thing. So 2 bases squared is equal to this square, which is 4 times 4 minus x squared. Solving for b, I'd get b squared is equal to 2 times that. So base squared is equal to what? 8 minus 2x squared, square root that. B is equal to the square root of 8 minus 2x squared, but I would do like basically base times base, like this times this would give us the area of that triangle. So this would be 1/2 base times base, so it would just be 8 minus 2x squared. What I might do here, I could just probably factor out a 2 just because. If I factor out a 2, that 1/2, and this is not this problem, the 1/2 and the 2 would cancel, so just have the antiderivative from negative 2 to 4 minus x squared dx. Volume is equal to, let's see, 4x minus 1/3 x cubed, evaluate from negative 2 to 2. And if I plugged in and solve that, I should get 32 over 3. All right. Last one. All right, you might want to try like doing this one on your own, just like try it, pause it, and then come back to it, or just watch and then practice on the assignment. All right, the cross section is perpendicular to the x-axis or isosceles right triangle with a leg on the base. Okay, so it shouldn't be too bad. Here's your circle, and then each leg of the isosceles right triangle, so those two are going to be the same, and then that's going to be the hypotenuse, but I don't really need that. I just need like leg times leg. So volume is equal to integral from negative 2 to 2 still, of 1/2, I can call this leg times leg, base times base times height, but they're the same thing. So the base this time is the distance from there to there, which we know is 2 square roots of 4 minus x squared. 2 square roots of 4 minus x squared dx. Okay, multiply this all together. If I do 1/2 times 2, that's just 1, times 2 is 2, so the volume is 2, times the integral from negative 2 to 2 of this times this, which is just 4 minus x squared dx, which leads us to volume is equal to 2 times 4x minus 1/3 x cubed, evaluated from negative 2 to 2. And if you simplify this all the way down, we should get 64 over 3. All right, so that's it for this. The key is it's always the volume is equal to the integration from A to B, wherever your shape stops wherever your shape of the base, the shaded part like this, starts and stops from x to x, and then it's the area of whatever shape they're telling you to do. Then you just integrate it. So thanks for watching. If you have any questions, ask me next time I see you in class, and hopefully this helped.